A principal angle has a related acute angle that is 45 degrees, 30 degrees, or 60 degrees, an exact value for the trig ratios can be found. This is also true if the terminal arm is on an axis, so either it starts at 0, 90, 180, 270, 360, or any continuation, any coterminal angles of any of those. Okay? So that leaves us open to a lot of different angles for which we can find exact values. Notice too that means you don't have to use a calculator, which for some of you might like, for some of you might be annoying, but let me tell you, in university math, you're not allowed to use a calculator for anything, even trig, so this is useful. One last example, and it involves us going the other way. So we're given the sine value, now we have to come up with the angle. So in the other ones, we were given the angle, and we had to come up with the exact value of sine. Now we're given the value of sine, but we have to come up with the value of the angle. How big is the angle? So I'm just going to rewrite this and talk about it for a bit. So the first thing to notice is that 1/2 is a ratio from one of the special triangles. Okay? Think about it. The different possibilities would be 1/2, 1/√2, √3/2, 1/√3. Anytime you see those ratios, or like 1 or 0, you should recognize those as answers from a special triangle. So that's how you know you can use a special triangle. So then you got to say, well, which special triangle is it? Well, it's not the isosceles one, because that's √2, 1/√2. It's the one that was the equilateral cut in half. So this is 60 in this corner, 30 up in this top corner. This was 2, this was cut in half, so it's 1, and then with Pythagorean theorem, we found this was √3. Okay? So I always just draw my special triangle. So now between 0 and 360 degrees, there's two places where sine can be equal to 1/2. Sine can be equal to +1/2 in this quadrant. So here's the first possible θ1. Or sine can be equal to +1/2 in this quadrant. So there's the second possibility, θ2. Okay? Because sine is positive here and here. In either of these quadrants, sine would be negative, so we don't need to draw a terminal arm there. So how do we go further and solve this? Well, you might be inclined to divide both sides by 2. Okay? This is a very natural thing, but you can't. Okay? You might be saying, why, Mrs. Weems? Okay, 2x is the argument of sine. The only time you would be able to divide by 2 is if you had 2 sine x equals 1/2. Then you would divide both sides by 2, because this 2 is on the outside. So you'd have sine x equals 1/4. But this 2 here is in the argument. Okay, so we say that 2x is the argument. So therefore, we can't do anything to get rid of the argument. We just have to solve this as is. So when this happens, when you have an argument other than just a plain x or a plain theta, we say let u be equal to 2x. So now we're going to solve the question sine u equals 1/2. Okay? So in fact, this is really u1 and u2. One love. Okay. u1 and u2. You'll see why in a minute, okay? So now I'm going to solve for u. Well, u is just u1 here, because it's in this quadrant, is just the inverse sine of 1/2. So if you go back to our special triangle, which of these angles has the sine of 1/2? 60 has a sine of root 3 over 2. 30 has a sine of a half. So it's 30 degrees. So therefore, U1 is 30 degrees. Okay? Now we can find U2 by using the fact then that its related acute angle must also be 30 degrees. So U2 then is 150 degrees. Okay, because just 180 minus 30. But now we have to solve for x. So remember that we let u be equal to 2x. So therefore we just set each of these equal to 2x. So 30 equal to 2x. All right, so then x equals 15 degrees. Then we let 150 be equal to 2x. So x equals 75 degrees. So here's x1 and here's x2. All right. So we actually have, I should have let that just be between 0 and whatever. There actually are 2 more values, but we haven't found them yet. So I'm just going to change this question to solve or find 2 values for x. Okay, because there's actually 2 more answers to this, but you won't really understand that until our next unit when we draw the trig function, so we'll just stop there. Okay, so again, you cannot divide by 2 because 2 is in the argument, so you have to introduce this u. So now you're just solving the sign u equals a half. So you find u, and once you find the values for u, you just use this to convert it back to x. Okay? So watch that example multiple times if you need to. Write down any questions you might have, and hopefully the homework will come a bit more naturally to you. So thanks for watching, and I hope you learned lots.